Okay, so you should be on page 19. We're looking at the order of operations. And we're going to start in our notebooks 1-3, and we're talking order of operations. Okay, now, like I said before, you guys, something should pop up automatically when you hear order of operations. And I hope it's that acronym, which is Pemdas. Some people say Pemdas. It doesn't matter. Please excuse my dear Aunt Sally. I don't know if you remember last year I made you guys come up with your own acronym. Like pigs eat mashed donuts at supper. Some of you pandas eat. So whatever the acronym is, you got to remember that's the order of operations. But why do we even use order of operations? Let me give you a problem a couple times, and let's see the value of it. Okay, so go ahead and write this problem down twice. We're going to work it out two ways. I'm going to ignore order of operations. I'm not going to think about it right now. We're just going to work this problem out two ways. Okay? Today, I feel like addition is important. So I'm going to go ahead and divide 16 plus 5, 21 times 35, 735. So that's my answer for that one. Okay? I think addition's superior, so I'm going to go ahead and do that. Okay, then the second way I'm going to do it, this time, you know what? I feel multiplication. I feel it. I feel its power. So I'm going to go ahead and multiply these two together, 175, and then I'm going to add the 16 as my second step, 191. That's my answer here. Okay, I said, bless you, I said ignore order of operations. You just do these problems. Okay, right now I don't see the value of order of operations because maybe some of you like that way better, some of you like this way better. It's preference, it's like opinion. And if I were to read this answer, let's say this was like number 1, and I said, all right, today guys, number 1 is going to be 735 or 191. That's easy to grade, isn't it? Like you just pick one or the other. If they don't have it, it's wrong. But you guys already noticed that at the end of 7th grade and into 8th grade, if you look at any of these problems in your homework, these problems are extended. Okay? A lot of operations going on. Long algebraic expressions that you have to funnel down. So we'll have 10 different answers. All right, number 1 is blah and blah and blah or blah or blah. And then you're like, Mr. A, did you say... It's just getting really confusing. So we have to have an order, a standard that we use to work these out. Okay? So guys, what's that acronym we know? That's fine. Mashed donuts. Ooh. That was not what I wanted it to do, although that was kind of cool. All right. So PEMDAS. You guys, again, should know this acronym. We're going to review it, and I think you guys know it pretty straightforward. But there are still a couple spots where people have trouble with, even on this homework assignment today. What does P stand for? Parentheses. Okay, parentheses. All right, E stands for exponents. M. Yeah, and I'm going to use the verb form, so multiply. So we multiply next, then what do? Divide. Then we add, and then subtract. All right, so you guys see what this acronym stands for. We're all good with that. No problems there. Okay, the first step, parentheses. We got to clarify some things here. Parentheses, they look like this. Ta-da, those are parentheses. But aren't there other symbols of inclusion? Do you guys remember what those other ones are? They look like this. Brackets. There's another level, brackets. And then the other level, braces. By the way, I'm going to apologize early. These are not too bad at braces. Like, I like the way these look. But there are a lot of times where I draw these out on the board. They don't look like this. That's okay. They're braces. I'm doing my best on those. Parentheses, brackets, braces. There's also another symbol of inclusion. It's actually the easiest one to draw. Hayes? Fraction bar. That's another symbol of inclusion. When we say parentheses, we're referring to these symbols right here. Technically, the radical sign is also another set of a symbol of inclusion, but these are the ones we want to know today. That's your first step. Start working within those parentheses. Now, if you have all of these or a few of these, you got to work within the parentheses first, then the brackets, then the braces, okay? If you have multiple sets of these. All right, that's the first step. Second step, exponents. Exponents, your powers. We talked about those last week. So deal with those powers, square, cube, to the fifth, to the 10th, whatever it is, deal with those. No problem so far? We get this?
Yeah.
Okay, now, what is the next step? The third step. Answer it clearly and be careful here. What's the third step? Taylor? Multiply or divide. Specifically in what direction? Left to right. Just like you're reading a book. You start left to right. Now, do you notice how Taylor said multiply or divide? It's not multiply then divide. It's multiply or divide left to right. Whichever one comes first, you do it. Left to right. That's the third step. And then the last step is what? Add or subtract, okay? It's add or subtract. Now, I get parentheses and exponents, but why doesn't multiplication get its own thing, its own step, or division get its own step, or addition, subtraction? Why do they have to be paired up? Do you guys know why? Yes, ma'am? They're closely related. Multiplying and dividing, very closely related. Adding, subtracting, super closely related. And we can actually, we can make them all multiplying, all dividing, or all addition, okay? All right, so those are your 4 steps. Now, Mr. A, I totally didn't get what you said. So on page 19, do you see that little chart there, that little yellow box? It says order of operations. If you like the word form better, how many steps are written down there? 4. 4 steps. So you can remember it that way as well. Yes, sir.
So the fraction bar is considered under parenthesis?
It's a symbol of inclusion. So you would have to do what's above it, you would have to do what's below it, and then the last step would be to divide. So like you simplify the numerator, simplify the denominator, and then those 2 numbers get divided, unless it could be left as a fraction, like a proper fraction, which you will have an example of. Okay, you guys good on this so far? This is all talk. So far we've been talking, now it's time to work.
Yes.
So let's look at example number 1. I like that enthusiasm. Example 1. All right. So this one right here, 5 times 7 minus 6 divided by 2 plus 3 squared. Okay, so here's our problem. Okay, first step, parentheses. Are there any parentheses? No, move on. Exponents, any? Yep,
Yes.
we have it here at the end. So we have 5 times 7 minus 6 divided by 2 plus 9. Remember, 3 squared means 9. 3 times 3. Next step. We're done with exponents, so the next step is what? Multiply or divide left to right. So here we have 5 times 7.
Equals 35.
Good. And then 6 divided by 2.
Equals 3.
And then we have plus 9 at the end. Not too bad so far. Yeah, last step is to add or subtract left to right. So we do the 3 plus 9 first. No, you do the 35 minus 3 first, right? You do the subtraction or addition, whichever one comes up. So 35 minus 3. And then plus the 9. 41. So instead, guys, of having several different answers based on your preference, we have one answer, and it's based on order. Okay? Is order good? As much as my son hates when I say, all right, Ezra, in the store you should walk orderly, or you should walk, because what happens is if he runs, and he's done this before, what happens if he's running in a store? What could happen? He could fall down. He could run into something. He could run into someone. And even if he doesn't hurt himself, he could hurt someone else. So you got to have order, right? Order is good. Where does order come from? It comes from God. You know, and this is what's kind of cool. You know how people say the beginning of the universe began with chaos? That goes directly against God's character. So to say that it came from an explosion and caused all this cool stuff to happen is incorrect, and it's against his character. But to say that he made everything and spoke everything in order, that shows his character. So that reflects God. I'm going to put up order. That's going to be our first word that goes on that board. All right. Questions on that one? Good on it? How many of you were like, that wasn't too bad? That was kind of like, I can do that. Those ones aren't too hard. Okay, then they're going to do this to you. Example 2. All right, example 2, I'm going to write this one out. You can write it down as well. Yeah, and that's the beginning now. What I do appreciate, and I'll be honest with you, some of my favorite lessons are the first lessons in Algebra 1 or Algebra 2, because what they do is they take familiar concepts, order of operations in this example, and they make you do them just like you've learned them in the past, but then they just they up the intensity. Let's throw some more of them at you. Let's get some fractions going on, decimals. So that's good for us. It expands what we already know and puts it to the test. But here I'm looking at this and thinking, what do I do first? Okay, so first step is what? Parentheses. So we see these brackets, and then we work within those. So we have 8, 6 squared minus 3 times what in the parentheses? Good, 7 divided by 8 plus 3. All right, so that was your step. Next step. Yes, ma'am?
I thought you were supposed to do extra.
So you first do parentheses. So we found these, and then we found these inside of that, so you can get that done. But let me give you a little hint. Some of you are going to start noticing, hey, can't you do these two at the same time? Technically, yes. Okay? So that idea, if you would have done this and that at the same time, it would not have affected your answer negatively at all. Okay, but what do I do next? So I get rid of that, so I have 8. Then I have my 36 minus my 21 divided by 8 plus 3. Let me give you an error location, a possible error location. I'm going to be honest with you right now. I was working out some of your problems, and I was doing it this morning. I was trying to go kind of quickly, and I did something. It was like this problem. I made a critical error. I worked this one all the way down. I was like, oh, good, I got it. Checked my answer. It was wrong. You know what happened?
You forgot about the 8?
Close. Something with an 8. Him. You know what happened? I interpreted this as a subtraction sign. It's division. But you know what was nice? I saw my funnel, and I looked at my answer was wrong. So I went backwards. Oh my goodness, Then I corrected it, got my answer. So this is what I had to think. I don't know how many times I told students, make sure you know what operation you're performing. Make sure you write it carefully. And I made that mistake, so Mr. A grew a little bit this morning. He's like, Mr. A, all that talk about you telling students, hold on, all that talk about those students doing operations, making sure it's clear, make sure you do it yourself. I'm like, okay, yep, got to do it myself too. And so through my failure, I can learn. And now I'm like, okay, be careful with those division signs, because it's very easy to make these little dots light in my writing and then totally forget them. All right, but next, what would I do?
Would you subtract 36 and 21?
Yes, I get my 15 here divided by 8 plus 3. All right, here's a little part that can, maybe some of you are seeing, you see something there. You're like, I know. Is there something that can help me out here? What's 8 times 15? 120. 120. And then divided by 8 is 15. Okay, you see something here? How many of you see it? Okay, what is it? What am I seeing here? Yes, ma'am. Alex. Okay.
You cross off the 8s.
What? You don't like 8s?
No, there's so
Okay.
many.
Remember here, guys, it's not that these numbers are necessarily just the same. It's not like you just, 8s, they can all go. Or, it's the order of which it's written. No. Look at here. What's 8 times 15 divided by 8?
15.
It's 15. So I'm left with 15 plus 3, which gives me my 18. So you could have done 120 divided by 8. Oh yeah, 15, and then plus the 3 equals 18. You could do that, but you also see inverse operations, right? Okay, good eye. Okay, questions on that? Okay, let's talk a little geometry. Your favorite, right? Guys, I want you to know that in next year for a lot of you, or at least 2 years by 2 years all of you, you're going to take geometry. You're going to see that there's a tie between algebra and geometry. A lot of people think geometry is this, algebra is that. Yes, they are different, but they relate in many ways. Here's one way they're going to relate. So look at example number 3. And I'm going to emphasize some things that we looked at last year, and I hope you remember. If you don't, I hope you get it down this year. Okay. Example 3A. The figure at the right is a rectangle. Okay, we know that. That's good. A. Find the perimeter of the rectangle when S equals 5. Okay, how do you find the perimeter of a rectangle? Well, how do you find the distance around a rectangle? You add you add all the sides. So in this case, what's the length in this rectangle here? S plus...
Would it be 8?
Yeah, from what we know so far is S plus 3. And then they give us a number. But it's S plus 3. What's the width?
Millimeters.
S. Yeah, it's all measured in millimeters. So yeah, we're talking millimeters, so pretty small. Okay, don't you have to double the length and double the width and add those two together? Okay, I'm coming up with an algebraic expression for this, okay? So S equals 5, and you could have put 8 here and 5 there. But no matter what S equals, I can use this little formula. We'll look at that later on this year as well. Okay, you guys said S was 5, because that's what they told us in the book. So 5 plus 3, and then 2 times 3. Why did I put parentheses here? There are no parentheses here. Did I just add parentheses when I didn't need them? Yep.
S, that's 3 is supposed to be S, so it's like multiplication.
Oh.
So you might think it's 23.
Yeah, it's very easy to say if you write 2 and 3 next to each other, naturally you think 23. So if it has these symbols in between, use your, it's 5, yes. Oh, I was noticing, why are all these people looking at me like something's wrong? Okay, so 5, thank you guys. All right, so now what we're going to do is use order of operations. So what do we get? What do we do first?
You do the parentheses.
Oh my. All right, now what do you do?
Now you do multiplication.
Yeah, you can multiply these both at the same time. You get this, add them up together. 26 what?
Where?
Millimeters.
Oh.
We're talking about perimeter, which is the distance. Just use the units. No square. But some of you are thinking, wait, I thought we talked about square units last year. We did. Look at B. What does it say to do for B? Find the area. Oh, that's where they play in. All right, the formula for finding the area is what? Do you guys remember how to find the area of a rectangle? Yes. Yep. Length times width. Isn't that the length times width of that particular rectangle? Okay, so what's the S stand for again? 5. So we got our 5s going there. Order of operations, 5 times 8 gives us a big fat 40. 40 what?
Cubic millimeter, square millimeter.
Square millimeters. Square millimeters. What I liked is that you guys knew it was not just millimeters. I'm glad. With area, you're dealing with this 2 exponent, and you read that square millimeters. Okay, 40 square millimeters. So what that means is these little square millimeter units, I have 40 of them in that rectangle. Okay, that's the area. You guys okay with that? Do you guys remember this from last year?
I do remember this.
Guys, I'm getting worn out. All these numbers and writing and all that stuff, it's wearing me down. It's time for you to show me if you really understand this. I want you to do, this is still in your notes, not in your homework. Do number 9. Number 9, I think it's on page 19. Oh, not 19, sorry. 21. 22, yes, we finally got it. Number 9 and number 22, work that one out. And we're going to look at it together, but I want to see if you guys can get this answer on your own. Number 9 on page 22. And then we'll work on our homework. So as you're working on it, just make sure you're careful on what you write and what operations you perform. And then if you mess up, you can just go back and correct it step by step. Yep.
What do you do if you're done?
Actually, if you're done, you can help me out. What do I do? I'm clueless. Yes, sir.
Well, it gives you the numbers for the X.
For the
Variable.
variables, good. Oh, yeah. Oh, W is 12, X is that. All right, so I'm going to substitute. Okay, so X is 5, Y is 6, and Z is 4, and W is 12. Okay, all the numbers where they belong? Okay. Oh, we've done this before.
Oh, yeah.
Okay, so what do I have to do here? Riley.
The 2 times 12
Okay,
and 6 times 6.
okay.
And could you do the 5 for the second?
What a great question. That's actually something I was going to ask. Can you do all 3 of these at the same time? Let's see. What do you think?
Yeah.
Okay, why? I thought you had to do exponents and then multiply, divide. And parentheses, although they are there, there's nothing to simplify within them. Hayes? Okay, so let's see here. We get 24, we get here 25, we get here 24, and then this is what we get. Guys, this is multiplication. That's multiplication. What's that?
Multiplication.
It is shorthand multiplication, 5 times 5. So yeah, you could do it at the same time. And yes, these are 3 different terms. You remember that terms?
Mm-hmm.
Terms that we had terms on? Mm-hmm. Okay. So that's why you can do it at the same time. All right, so I have this problem. All right, 24 plus 25. Hold on. 49 minus 24. 5, 2, 25. Yay! All right, what did you see? Benson?
Well, you're adding 24 and you're subtracting 24, so
Ah.
you can just block out the 24 and your answer is 20.
Okay, inverse operations, you have 25. You add 24 and you subtract 24, you're left with 25. Okay. Could you do it 49 minus 24 and get the same answer? Yeah. but you can just look at your inverse operations. Great job, guys. How many of you got 25? Okay, if you did not get 25, or you're still not getting some of these parts, we have some time to work, and then I can help you out. But your homework tonight. You know what I did on the last class? I lost this little paper that I have my homework on, and so I took 2 problems away. So it would have been 15 to 28, but I didn't know that, so I said it's 15 to 26, and then 35 to 37, 51 to 53, pages 22 to 24. Okay? So yeah, you missed out on 2 problems.
Do you want us to do till?
No, you do what's up here. Yep. You guys will benefit from that. Yes, sir. No, not today. I want you guys to really nail this down on your own, but you can ask me questions. I'm more than happy to help. Also, guys, are you allowed to look at the back for your answers?
Yeah.
Yes, don't be afraid to do that. It's totally okay. But I'm guessing if you miss number 15 and 17, that there's a pretty high chance you miss 16 and 18 because they're the same type. So use that to help you out. You shouldn't be getting all the odd ones right and then all the even ones wrong. That's not how it works. So we're going to end the recording.